Hi everyone, welcome to my new video series. In this project I am going to show you how to build an AI-powered robotic owl that automatically detects and scares away the bird and squirrels that keep eating the fruit and vegetable in my backyard. We will use the Arduino UNO Q as a system brain, running an AI model that detects birds and squirrel, and an ESP32 to control the owl decoy movement using Wi-Fi. We will build the entire project step by step. First, we will install Arduino App Lab and set up the Arduino UNO Q development environment and learn the basic of Arduino App Lab by running and modifying a simple LED blink application. Then train a custom object detection model in each impulse to recognize bird and squirrel. Then deploy the trained model to Arduino UNO Q so it can detect the squirrel and the bird in real time. Then design the robotic owl mechanism, connecting it to the ESP32 and establish a Wi-Fi communication between the Arduino UNO Q and the ESP32. At the end, we will put everything together and watch the AI-powered robotic owl detect and scare away unwanted visitors. I will be posting one video for each step until the project is finished. I will appreciate all your feedback. Let's get started. First, we will go to Arduino UNO Q download web page to download your Arduino App Lab. From the drop-down menu, you will select the operating system you using. I will use Mac. After downloading, select the downloaded file and start the installation. Move the Arduino App Lab application to the application folder. Connect the board to the computer USB, then launch the Arduino App Lab from the application folder. In board configuration, added the board name. I choose to use UNO Q1. In network setup, you added your Wi-Fi network name and also you put the password of your Wi-Fi network. For Linux operating system in the Arduino UNO board, the default name is Arduino, but you have to put your password, and you have to confirm the password you choose. The board will connect to the internet to check for any update and start installing all the needed update. After that, it will launch the App Lab application. As you can see, there is already pre-made example you can run directly in Arduino UNO from the App Lab. There is 3 ways you can run the app in the Arduino UNO Q. First one is a single board computer mode. In this mode, you can run the Arduino separately with a separate monitor and keyboard connected to the board. Second is connecting the board directly to your computer using a USB cable. Third, connecting the Arduino UNO Q to a separate power supply and connected using the Wi-Fi to the computer as the following. In the computer, start the Arduino UNO App Lab, then select Network. Enter the Arduino password, then the App Lab will launch the application. I will use this third method for all my future tutorials. To test our installation, I will select the Blink LED app and try to run it. When you select the app, you will see a README file explaining how the app works. Click the green Run button in top right corner. The app will start prepare the board to run the app. Once the app started running in the board, the text becomes green and the run button become red and display stop, and the LED will start blinking. If you click the stop button, the app will stop. So far, we finished the Arduino App Lab installation and run a simple app in our board. Next video, we will learn how to edit the blinking LED app and get familiar with Arduino app files.